I'd like to inform all of you that accelerators will be announced shortly. Okay. Good morning, everyone. Welcome to another webinar from Data Platform Geeks. It's been a wonderful ride organizing one webinar each day in the month of March. My name is Rohit, and I will be your host for just for a few minutes. And I have Satya with me, who will help us with the moderation, Q&A, and the overall execution of today's webinar. I guess a lot of people already know about the e-dominant systems and a couple of our initiatives. Under SQLMaestros, we have a lot of stuff related to Microsoft Data Platform, consulting and training primarily. We have masterclasses and accelerators. I would like to inform all of you that we will be announcing accelerators shortly. A link will be given to the community where you can take a short survey and let us know what kind of topics you want on these full-day classes of accelerators. We also have self-paced unique learning platforms called hands-on labs. They are all available on DataPlatformGeeks.com. So go ahead, create your free account, and you can access some of them. And Data Platform Geeks, as all of you already know, this webinar is organized by Data Platform Geeks. We also have a lot of free stuff under it. And we have our annual feature, which is known as Data Platform Summit, formerly known as SQL Server Geeks Annual Summit. This is its 4th year, and this year it's happening in the month of August. The dates for the conference are 9th, 10th, and 11th, and for the pre-con are 7th and 8th. You can see here that this time we have shifted to Radisson Blu. Last year it happened, in the previous years it happened at Nimhan's Convention Center. So we get a lot of participation at the summit, primarily because we have the world's best trainers, speakers, and consultants, and the industry stalwarts who fly down to Bangalore to deliver sessions. And the most noted here at the summit are the SQL CAT teams, the Tiger teams, and the senior product team members from Microsoft Redmond, USA, and supported by the global MVPs and MCMs. We are very grateful to our speakers who voluntarily give their time to the summit and deliver sessions for the Indian community. And you can see on your screen the DPG core team who work behind the Data Platform Geeks free events, and strongly backed by our teams at Bangalore and Kolkata. Special thanks to Microsoft for being very supportive of our community initiatives. And all of you are already members of Data Platform Geeks. So go ahead and access all the free stuff that is available on our website. And you can join these groups that Satya will put in shortly, the Facebook and the LinkedIn, where you can give us feedback or ask questions or answer for the community. So without any further delay, let's welcome Philip Seamark, who is an MVP from New Zealand. Over to you, Philip.
Hello, thank you, and welcome everyone. Thanks for joining the webinar. I do appreciate you taking the time out of your day to join this. I'm dialing in from Wellington, New Zealand. It's about 10:30 at night on a Friday night. Hopefully I won't fall asleep on you. But we're talking about my favourite subject. So now, I was going to be using some cricket data for this session, but unfortunately the England team didn't provide enough data, so I'm going to have to make do and generate my own for this session. Let's jump over and have a look at my screen. So please let me know if you can see this okay. This is just my introduction slide.
Yes, Philip. It's perfectly loaded. We can see your screen.
Wonderful, that's cool. So my name is Phil Seamark. I am a consultant here in New Zealand. I do Power BI and DAX training. I'm an author and also a Microsoft MVP, particularly in the Microsoft Power BI area. My contact details if you wish to follow up with anything you would like to that you find interesting from this webinar. Please feel free to email me at phil@redicad.com or reach out to me on Twitter. There's my Twitter handle. And if you are interested in anything in more detail from today's session, I cover it in much more depth in my Beginning DAX with Power BI book, which is optimized for particularly people coming from a SQL background. And there is a photo of me so you know what I look like. So what I'm going to be doing today is concentrating on just practical examples of DAX. I'm not going to be spending much time talking about DAX theory, things like filter context or context transition. There are plenty of sessions and webinars available to look at that. What I thought I would cover is actually practical examples of how you might use a variety of techniques inside DAX. We're going to be looking at variables, nested variables, different ways you can group and summarize data, joining tables together. We're going to touch on the difference between a calculated measure and a calculated column, and when you might use one or the other. We're going to have a look at some optimization and debugging techniques as well. So it's going to be very demo heavy. We're going to generate all the data that we need from within DAX. So I'm not going to connect to a data source and import any data. We're going to generate it completely within our model using DAX. The end result of the data is perhaps not as important as just the tips that I'm going to share with you along the way about how you can do some of these things like summarizing, joining, optimizing, etc. So let's jump over to Power BI. So I have a blank model here. I haven't got any data in this model. I'm going to bring everything in from scratch, like I said. And we're going to heavily use the new table button at the top to generate some data. So straight away, I'm going to click on the new table button on the modeling tab. And the first table I'm going to create is a numbers table, which I'm going to use as a utility table. So I'm going to call the table numbers, and actually if I drop this down we can have a bit more screen real estate. And I'm going to use a function called generate series, start with value 1, finish with value 100, and go in increments of 1. This third parameter is optional and actually defaults to 1 anyway, but I'm just sharing that with you so you're aware of it. Previously this was quite difficult to do, and you would have to use other functions to generate this sort of data. So the result of this is giving me a single column table starting at number 1, and it's going to finish at number 100. If I want to rename this column, I don't like the fact that it's defaulted to the text value. There is no rename function as such. What I can do is use the select columns function. The first parameter of this requires a table, and we're going to be using the output of the generate series function as that first parameter. And I'm going to call my column n and give it the value of the output of the generate series. When I click OK here, that's simply just going to rename our column. Hopefully I'm not speaking too quickly and you can understand my accent. So there we go. We now have a data model with a single table in it. Let's start creating some more. What I'm particularly interested in trying to generate is a sample set of sales data, semi-representative of what you might expect in a normal business. The reason why I'm going to generate it is maybe I want to do some load testing. Maybe I want to create some tables that I want to use that I can share, or that's not confidential, but I can equally test my measures against. So I can control the size of these tables and the content that goes into them. So now I have a numbers. First of all, I have a numbers table. Now I'm going to create a date table. So again, I'm going to go to the new table button at the top and say I want to now create a date table, and I'm going to show you. I'm going to start using variables, And to start with that, we just type the keyword var for variable. I'm going to call this base table and use the function calendar. This is very similar to the generate series table, where I just pass to a calendar function a date that I wish to start and a date that I wish to end with. I'm going to use the date function to start with 2016, the first month, or the 1st of January 2016, and my end date is going to be today. Now if I click OK here, I'm going to get an error. Because I've used the var keyword to begin a variable scope, I need to close it out with a return statement. So if I add a return statement, I can return that variable. And that variable at the moment is containing a table, which happens to be a one-column table starting on the 1st of January 2016 and ending, if I go down to the end, today, 23rd of the 3rd, 2018. So I want to add some columns to this. I'm going to continue to use the variable technique to add columns to this. So I'm going to type my next column, my next variable is going to be called, let's add a year column. I'm going to use the DAX function add columns, and that's going to want a table to add a column to. We're going to use the variable that contains a table already to add this column to. We're going to call my column year and give it an expression or a format or whatever the value is that we want to appear in every cell of every row in this particular column. And we're going to use the DAX function called year to extract the year from the date. Now this date that I'm using as a parameter of this function is the value from this column here when I go OK. Now if I click OK, nothing changes in my output. That's because I'm still returning the base table. I need to take the add year variable and say that I want to return this instead. So we now see that my table has a second column here. And if I scroll down far enough, there we go, we have some 2017s and probably some 2018s at the bottom. Okay. If I want to add months, I'm going to add 2 columns this time. So we go add columns. I'm going to add columns to this table, which happens to be the output of this table here. And we're going to create a column called month ID. And my expression this time is going to be using the format function, which converts other variables into string. So I'm going to format the date using the standard Microsoft format string standard to say I want to have the 4 year digits and 2 month digits as the value for that column. I'm going to have a column for month, which is going to be the start of month date. Oh, let's actually go format date, comma, month, YY, close that out, close that out. Now, with this new variable, if we drop that into the return statement, we should hopefully have 4 columns there. So we have a month ID column and a month column. Now I can, with the month column, choose to sort that by the month ID column, and I can now hide this one away. The sole purpose of adding a month ID column in this particular example is so that I can sort my month. Let's hide that in report view. Great. So continuing this pattern on, I can drop in a variable that's going to add a day. My column is going to be called start of week. Table. So you can see here I've got the same DAX expressions in variables, and I'm returning the variables, but I'm using a generate function over a base table to produce the same result. I will include this in the file that I upload at the end of the webinar, so you can have a look at the two approaches and decide which one works best for you. It's not a performance issue, it's just perhaps what you like to look at to maintain and look after. So we'll just park that out of the way. So now what I'd like to do is actually start working on a sales table. So what we're going to do is use similar techniques to what I've just used for the date table, using variables to build out the table. So let's start by clicking on new table, and we're going to call this sales. What I want the sales table to look like is transactions, one row per sale. So we're going to go var first table, and that's going to be generate dates numbers. Okay, and let's return that. Generate is a joined, allows you to join two tables together. So what I'm doing here, or what I'm attempting to do with this function, is to combine my date table with my numbers table. So by default, at the moment, what this will do, I know my numbers table has 100 rows in it, and I know my date table has as many rows as there are days between the 1st of January 2016 and today. So by clicking OK here, I should get a table that combines the two, and it will be however many hundreds of rows long. And let's have a look down at the bottom to see how many rows that generated. If I click on sale, that's not giving me a row total, but if I sort by day, you can see here that for the 1st of January, there are the same 5 columns that we just generated when I built my date table dynamically, but we've got the numbers table 1 to 100. And then it starts again from the 2nd of January, 1 to 100, etc. So here we go. We've got 81,300 rows. Now, I don't want to have exactly 100 rows per day. What I want to do is simulate some form of realistic number of sales today. So I want to have a random selection of rows per day to help me test my measures later on when I'm in my optimization phase. So I'm going to filter this table. The first parameter of filter being an iterator is always a table, and what I'm going to specify is that the value of n, have to get my commas right, I want to filter this table, that the n should be less than a random number between, let's make this easy, 2 and 7. And click OK here now. So what I've done here is I've introduced a randomized selection of numbers per sales per day. So now when we look at the 1st of January, we can see that there happens to be 5 sales. For the 2nd of January, we have 4 sales. For the 3rd, we have 3, and so on. So it's a mixture of sales. And if I want to get rid of the, all I'm really interested in is the date column. I don't want all these other columns. So to remove columns, I can use the same select columns function that I used earlier to rename. And the select columns requires a table to be passed to it, and the output of filter is a table. And I want to select a column which I'm going to call date, and just grab the date column and go OK. So back to my random number of days, random number of sales per day, but we just have a single column here. So let's add a product to this table. So add product. Hopefully you can read this okay. I hope the screen's not too small. So equals, going to add columns, the first table. So we're going to add some columns to my first table variable, which is currently a single column table. The column that I would like to add is going to be called product. Now what I'm going to do is introduce a new level of variable scope. So this is what we call nested variables. So I'm going to call this var make equals, and we'll assign this a random number between 65 and 90. Deliberately chosen these two numbers because it's the range on the ASCII scale that identifies the alpha characters A through Z. I'm going to create another variable called my model, and I'm going to format a random number between 1 and 5, and I'm going to just put a hyphen. I'm going to format it in this way. Now when I put a return value, this return value is returning the variable scope that I've opened with the make variable. It has nothing to do with the variables that I have external. I can reference the external or higher up scope. I can't reference it the other way around, but I'm going to return. I'm going to repeat the unichar make variable, which is the random number between 65 and 99. This unichar will convert it to an A to Z. I'm going to repeat that letter 3 times, and then I'm going to concatenate on my model. Close this out and return here. Cool. So you can see here what I have constructed in my add product statement is a model number that always has the same letter repeated 3 times with a hyphen and then a random number between 1 and 5. The output again is probably not as important as perhaps just recognizing that you can, within a function as a parameter, you can drop in and start developing some more complicated DAX as a nested variable. That can be very handy, very powerful. If I try and reference any of these variables out here, var x equals this, it has no knowledge of it. It doesn't recognize that, variable. Whereas if I use a variable name that is at the current scope level, then it's fine. So now let's add a quantity column. So it's, if we want to add a quantity to our sales table, let's use the add columns pattern again. We're going to add columns to the last variable we used. I'm going to use QTY as my column header. Again, now I'm going to introduce a new level of variable scope. So var q, very imaginative names, ran between 1 and 1000. And return, this return will return the variable scope that I opened here with the var q. And I'm going to return 5 minus int log q, comma 4. I'll explain what this is doing in a minute. Just play the bracket game here. Cool, I think I have everything. Let's return now the latest variable that we're working on. Okay, so what I'm trying to do here is use a logarithmic function to try and distribute sales unevenly or logarithmically between 1 and 5. What that means is usually when you're selling something, you have the highest number of single purchases, you have a smaller number of sales where someone has bought 2 items, less sales where someone has bought 3 items, and so on. Let's just test to see whether this has actually distributed my data fairly nicely. So if I jump across to the Power BI canvas, let's just get rid of that. If we have a look at the quantity column as a bar, let's put quantity in the axis. Here we go. So we have in our data 2,000 rows where we sold 1 item, 1,000 rows where we sold 2 items, 300 rows, 375 where we sold 3, etc., etc. So we have a nice logarithmic scale. So it's trying to generate some semi-realistic looking data, and this is kind of going with the earlier work to maybe try and mix up the number of rows per day, so that when we are testing our variables, we are getting a little more realistic with our data. Okay, so let's finally add a price column. And what I have done here again, I've chosen a random number between 1 and 10,000. You can use scientific notation, and I'm using the divide function. If you're not aware of the divide function, I would recommend you use it instead of the slash operator. It handles the divide by 0 error with an optional third parameter much more elegantly than if you were to use a slash operator. We've named the column price. And finally, what I am going to do is add a 5th column to our sales table. Now, the interesting thing about this final column, which is giving us a total, it's a calculation based on the column created here and here, the price and quantity. So when we add this and add total to the final return at the earlier level of scope, here we go. So where we have a quantity of 2, the price was this amount, the total was double. So there's our sales table. And what I should do, just to be tidy, to keep things clean, is make a relationship between our sales table and our date table, and we can start creating reports and visuals as well. We can hide the numbers table so it doesn't appear in the field list. And note the month ID column doesn't appear there either. Okay, so now let's have a look. Now that we've generated a sales table, a really good, useful tool, if you particularly want to optimize your Power BI report, is to create summary versions of your table. Often I see data models where a large fact table or sales table might have 1 million, 2 million, 3 million, 4 million rows, lots and lots of rows, and people start generating visuals over the top of them, but often the visuals are summarized to a day at the lowest grain, or month, or even year. Now, when people use those visuals and make selections and make filter selections, every single point in that visual has to recalculate. It's a calculation that needs to be reprocessed and will read the entire table, a bit like in SQL we're doing a table scan. Now, DAX is very fast. All the data is sitting in memory, so it can handle it very fast, but it can handle it much faster if you create summary versions of your tables and pin the visuals that never go down below year or month or day to use the summary versions of those tables. So I'll show you what I mean by that. So we have a sales table that happens to have approximately 2,852 rows. Now remember, I generated this using parameters. I could easily turn this into a 2 million row table simply by using a larger numbers table or that filter when we join dates to numbers. I could have a much higher criteria to generate, quickly generate much more data. So what we're going to do here now is create a summary table over sales. So again, we go new table, and I have overwritten that. So we're going to go daily summary equals summarize columns. We're going to summarize we're going to summarize it down to date. And if I close this out and go OK, what that's going to do is, again, create a new table, but group down to the single day column, the single day granularity. Let's introduce a column into here called daily revenue. And we're going to use the expression sum our total. And here we go. So this value that we're seeing for the first is not one of the individual rows from our raw table. It is the summarized version. Now, if I create a measure that plots my revenue by day, it's going to perform a lot faster if I was to use the daily summary table versus the new table, the original table. And I'll show you what I mean by that. I will need to create a relationship, because in the model now, here is the new summary table that we've just generated. I will fix up this relationship to make it a single direction, many to one. Cool. So in our daily summary, if I drag the date column and daily revenue, here we go. Turn that into a slicer, a filter. Cool. And if I throw a measure on top of the summary table, there we go. So we're going to here we go. So this particular piece of DAX is going to perform a rolling average. It's going to have a 14-day rolling average of the daily revenue column. If I add that now to the model, drag it onto the visual, you can see here that we have a smoothed out line. We have a calculated measure sitting on a summary table of a table that we've generated from scratch using DAX functions. So there's a lot of dynamic DAX going on here. Now, if I was to run this same rolling average of revenue on our original table, it's not going to perform as quickly, especially if our sales table gets into becomes a much larger table. So I do recommend using or considering summary tables if you are struggling with a slow running report. Although at the moment you do have to code your calculations specifically to say which summary table you are going to be using. Microsoft did announce 2 days ago they are going to be looking at bringing in-memory aggregations to Power BI later this year. So that's going to be an almost inbuilt version of the same thing, using summary or aggregation tables to help optimize and speed up reports. So that's pretty exciting. Let's have a look now at the often asked question in Power BI. When should I use a calculated column and when should I use a calculated measure? Now the easy answer is it depends when you want the calculation to be executed. A calculated column will run only once and will only run as part of the data refresh or data load. So as you're importing data into your model, the calculated column will execute at that point, and then when it's finished calculating, the numbers will be stored in memory and they will be static. They will not change. So when you then start applying filters over the calculated column, they will not have any effect. So what I'm going to do is add a calculated column and a calculated measure to the daily summary table. Jumping back to when these calculations are executed, calculated measures only ever execute at the time a visual is loaded or a visual is interacted with. If you happen to have a line chart that has one line on it with 10 data points, the calculated measure will execute once for every one of those data points at the time the visual's loaded. If you then make a slicer selection or a filter selection, the calculated measures will recalculate. But I'll demonstrate that. What I have here, I'll just get my notepad again. Hopefully you can read this. I'll make this a little larger. So the daily summary table that we've just created, what I'm going to do is create a cumulative revenue. I'm going to create that as a column, and I'm going to have a cumulative revenue as a measure. And when we look at the code for the calculated column, which is the top half, the calculated measure code is at the bottom. Now, these are practically identical. The calculate row, the expression is the same. Sum of table and column, sum of table of column. We're going to filter. We have a slight syntax difference between measures and columns to decide what we're going to consider. And but essentially, they follow a very, very similar pattern. So let's add this calculated column to our table that we just created, the daily summary table. So we're going to go add column, paste this in. I'm not spending too much time on the particular of the syntax because I will upload this data to the upload area at the end of the measure. So daily summary, why is this complaining? Sum, daily summary, daily revenue. Okay, if we have a look at the measure, here we go. So we can actually see the 1st of January, the first of the year, the two the values in the two rows match, but then for the second day, we can see that the value is starting to accumulate by the amount that's in the daily revenue column. So that's working nicely. So now if we add a calculated measure to the same table, new measure, and we can see that here. And I just need to fix this. So it's the same calculation. Okay, doesn't appear anywhere. It hasn't executed anywhere because it's a calculated measure. All we've done is enter the metadata or the code in, but it has not yet executed. Whereas the calculated column, it's already executed. It's not going to execute again. So let's plot these two. Let's plot these two items, these calculations, onto a chart. So if we put a date on an axis, drag in our calculated column and our calculated measure. All right. Now all we see is a single line here, and that's because we have two variables producing the same result. If I copy and paste that, turn that into a grid and park it over here, we can see the calculated revenue as column, calculated revenue as measure. They're producing the same result. The column didn't do anything except simply read the values that were pre-calculated earlier when I loaded the column. The measure, however, has calculated every single cell here when I created this visual. And at the moment, there is no difference between them. They're producing exactly the same value for every row for the visuals the way I have built them. Now, where this will start to become different is when I introduce a filter. So let's go and drag year up into here, turn that into a filter. Let's make it a list. Okay, I'm now going to select 2017. Okay, so here is a difference. The column is jumping straight to the value that we calculated earlier for the 1st of January 2017. Remember, we started this series at 2016, so it's already up. It's already accumulated up to here. It's just spitting out what it calculated 5 minutes ago, whereas the measure is starting from scratch, and it's executing the DAX code based on what it can see, and what it can see is what's been filtered by here. If we select 2018 and 2016, you can see the behavior, and obviously if we go back to 2016, these will now be in a line. So calculated measures do not store anything in memory. They will have no effect on the memory size footprint of your data model. All they are is a bit of calculation that's waiting to be executed, and they only are executed at the point in time that you drag them to a visual or need to display them. But it's at that time they will start using CPU. So if you have a value that you want to display on in your model and in your report that you don't want to have influenced by any filter, then by far the best thing to do is to create it as a calculated column and get it to process and execute the calculation at the time the data is loaded in, well before your user is even going to see the report. Whereas if you must create a measure that needs to respect perhaps some filter selections that people are playing with, and this is a really common requirement, then you do need to make it as a calculated measure. If it's slow, then perhaps you could consider things like maybe use a summary table or some of the other optimization techniques that we will have a look at. Let's now have a look at some of the tools that you can use to optimize. Now, there are the two tools that I'm going to showcase today. The first is DAX Studio, and the second is SQL Server Management Studio. Both tools are free. Both tools are ideal for working with and optimizing DAX. So let's fire up DAX Studio and look at what it can be useful for. So I'm just going to close my DAX and open it up. Okay, so this is the DAX Studio window, and I can connect directly to the model, this Power BI model that we were just working with. So we're going to connect to that, and I can see I can write my query here, and there's a whole bunch of support features and options around that to help me write my DAX better. We can see the tables. Excuse me. We can see the tables that we have generated, and some of the neat features about DAX Studio are that you can run your queries and output the results to files. So if you just want to query your model and suck out some CSV or TSV data that you want to use external from Power BI, then this is a good approach. DAX Studio shows you the connection port that your Power BI desktop model is listening on. So Power BI will every time you open it, we'll jump onto a different port. So if we see down here, DAX Studio is showing us that our DAX model, our Power BI desktop model is listening on port 53257, and we're going to use this number to help connect with SQL Server Management Studio. But let's have a look at some queries now. So I mentioned earlier the difference between a calculated measure and a calculated column. So let's see how DAX Studio can show us exactly what's happening under the covers. So I'm going to paste in the code that allows us to execute the calculated column that we just built. So this here is going to return a table with 1 row per day, and it's going to bring back the value from this calculation but equally we're going to be able to see the calculated measure as well. So let's run this. And in fact, I'm going to clear my cache and run, because this is important if you're going to be doing debugging and optimizing. So let's run this. And I can see very much a table very similar to what we just saw in the Power BI desktop model. So we can see the two numbers side by side are exactly the same. But how do I know which is faster? How do I know which took more time for the underlying DAX engine to work with? So let's comment out the calculated measure and just run the column on its own. But using DAX Studio, we will turn on the server timings and we will turn on the query plan so that we can understand and look into exactly how much work the DAX engine needed to execute these. So we will run this with a clear cache, then run. Okay, so here's our results here. Let's jump to the server timings. Now the box I want to draw your attention to is this little box down here. If I can do a square box. There we go. And more importantly, these numbers here. So FE is short for formula engine. SE is short for storage engine. In short, the formula engine is number crunching, executing your code, running the calculation, whereas the storage engine is just the simple exercise of going and grabbing a number and retrieving it. Because this is a calculated column, we've already run the calculation. So this is very fast. The entire calculation only took 8 milliseconds. And of that time, very little was spent in the storage engine. A little bit was in the formula engine, but it was very quick. Now let's have a look at the same calculation, but as a measure. Run this. Okay, the numbers are quite dramatically different now. So rather than spending 7 milliseconds in the formula engine, to satisfy this query, it needed to spend 264 milliseconds in the formula engine. And that's because it's actually executing the code as part of this query. Now, if we were able to measure the calculated column when it was originally created, it probably took about this long to run, but we only ran it once, and then it was the numbers were locked down and stored in memory. Whereas here, we're spending a lot more time in the formula engine. So when you are optimizing your DAX formulas, a really good thing to do is to bring your code across here into DAX Studio, turn on your server timings, query plans and server timings, get some baselines, have a look to see how much time it's spending in the formula engine versus the storage engine. And if you can shift that across using different functions or different approaches, then I'm sure you will find your overall query times coming down. And faster query times means faster reports and happier users, better user experience. Another neat feature about the DAX Studio is you also see the pseudo T-SQL code as well. So it's showing us here what it's converting this summarized columns dates calculate measure into. It is the equivalent of select date and sum daily revenue from table, where table date in, and these happen to be days of the year. There are too many. So that can be quite a useful way to understand what's going on in the DAX engine. Another neat feature I like in DAX Studio is you can format your query. So you hit the format query button and it will attempt to tidy the query up. Normally if you have an uglier query, let's paste in a different one. So if we paste that in and hit the format query, no, that's not working for me. We'll move on. I talked about the query plan. If you've spent any time looking at T-SQL query plans, you have the luxury of a nice graphical query plan. If you're just using Power BI or Excel, you don't have the ability to see the query plan at all. Whereas at least in DAX Studio, you get a verbose text query plan. There's a logical and a physical query plan. If you do spend some time looking at this, that will probably quickly start to make sense. Importantly, it can it can help you diagnose and understand maybe moving a filter into a different part of the query higher up might start to reduce your row set and IO overall. So really just wanted to make you aware that this is a useful area of DAX Studio to come to. You can run multiple queries. We can have a look at DMVs. Again, this is a useful thing in the T-SQL world. A DMV allows you to query information about your model. Some useful DMVs, if we scroll down this list here, I've clicked on the DMV, we can find in the tabular model measures. So I just double click that, and it's going to give me select star from system.tabular model schema measures. If I run this, oops, what's happened here? Oh, the format's just come back. That took some time. Let's run this. So the DMV, the result of this DMV is we can see every single measure that's in my model, including the code. Now this can be very helpful for creating documentation, because you can output this to a file. You can say, okay, for this particular model, here are the measures, here is the code that's being used. You can drop it into a data catalog or share it with an analyst who's going to be using your model so they can get a better understanding about what it is they're looking at. So that's, again, another handy feature of the DAX Studio that you get out of the box. You can run multiple queries, but let's have a look at SQL Server Management Studio. I'm wary of time. So SSMS, so remember I took a note of the port number down in the bottom corner, 53257. I'm going to bring my SQL Server Management Studio server over here. We can connect to Analysis Services 53257, and we can browse my Analysis Services model, including the tables and rows, and browse these. We can even write MDX if you enjoy writing MDX, which I certainly do. So here we are. I'm actually executing. I'm not writing DAX against my Power BI desktop model, and I'm querying here the rolling average of revenue calculated measure that I only created 20 minutes ago. Remember, this model didn't exist until before this presentation. And we can use a very handy feature of SQL Server Management Studio is, in fact, the profiler. So if I start my profiler, hit run, make sure I can pick some useful events. So query events such as query begin and end. Let's run that. Jump back to my Power BI desktop model and start clicking on some visuals. Jump back to profiler and look what we have here. We have the DAX that Power BI desktop canvas is generating from those visuals to execute against the model. I can copy this code, drop it back to, say, DAX Studio, paste that in, and with my query plan and server timings on, run that query. It's going to spit out some results, and somewhere here, that's all it spit out. Actually, that's all that query actually spits out. And we can see in the server timings how much time it's spent here, where, there. You can really get down into the DAX with these two wonderful free tools. Now, I'm conscious that we're nearly out of time, so what we can possibly do is go to questions. Is the moderator, are you able to, have you got some questions built up in the chat window so far, or how are we looking for time?
Yes, no questions still now, Phil.
Okay.
We are about to, so we have only 1 minute.
Sure.
Sure, we can close this.
Well, I thank everyone for coming along today. I hope that some of you, or you all, were able to take away a couple of things, tips or tricks that you perhaps haven't seen or used in DAX before. you're certainly welcome to contact me directly if you have any questions or you'd like to understand more about some of these. I will load the PBIX file that I've just generated, including the text file with the code, so that you can spend some time looking at maybe some of these components in much more detail. But yeah, I really do appreciate the time you've taken to join the webinar today. I am coming to Bangalore for the DPS Summit in August, and I look forward to hopefully meeting some of you as well. It will be my first time in India, and I'm very excited about it. So how are we going for time?
Yes. So time is up, Phil. So before taking any questions, Rohit from our team will take over, and he has a couple of slides to
Wonderful.
show. So he's sharing his screen now.
Cool, thank you.
So after that, you can take your questions.
Cool.
Yes.
Thank you so much, Phil. It was really kind of you to spend time with the audience here. And I would like to inform our community that Philip is also one of our speakers at the summit this year. I'm sure you already mentioned that. Also, let me just quickly take you through the list of pre-cons and our other speakers at the summit this year.
Okay, yeah, I understand.
So first pre-con, that would be Troubleshoot and Optimize SQL Server by Dimitri. He will be taking that. He's a Microsoft Certified Master from USA. And migrating your on-premise database to Azure, that will be taken by our Principal Program Manager from Microsoft USA, that is Sunil Agarwal. He was our most popular speaker at SSGS 2015 and 16. And Power BI from Rookie to Rockstar, that will be taken by Reza Rad. Leading Edge Data Science with Microsoft Tools, that is Dr. Leila Itati, MVP from New Zealand. And A Day of Intelligent Data Integration with SSIS and ADF, that is by Andy Leonard. We have Azure Cosmos DB Workshop by Madan Gajendran. That is, he's an Azure Cosmos DB expert. And again, Dr. Leila Itati will be taking building intelligent application using the Microsoft AI platform. And we have Practical R for Everyone by Steph Locke. She's an MVP from UK. And Building a Scalable Data Architecture in Azure by Sanjay Mishra, the Principal Program Manager from USA Microsoft. We have Linux for the SQL Server DBA, A Brave New World by Joni D. Anthony, MVP from USA again. And Zero to Analysis Services by Peter Meyer, another popular speaker at our summit, an MVP from Australia. And the final pre-con will be taken by Denny Cherry on high availability and disaster recovery. So we have 12 pre-con this time, and we have more speakers to be announced, which will be done gradually. So you can go ahead and join these groups, the Facebook and the LinkedIn groups. Like I mentioned, you can give your feedback, ask questions, answer the questions. And a word from our sponsors, SQLMaestros. Like I mentioned before, we have advanced trainings, hands-on labs, on-site training, SQL Server, health check, etc. And the hands-on labs can be accessed on DataPlatformGeeks.com. We also have demos, so you can create your free account and access them. And thank you so much for your time. And I would like to hand over this to Philip again to take the Q&A. You can use the Q&A column to ask your questions. Thank you so much.